Now I'd like to introduce Philip Kirken, who is the Chief Executive of Hardide Coatings, and he's going to take you through the presentation. I shall pick up at the end and fire the questions at him. So keep them coming in. You don't need to wait till the end of the presentation. You can type in your questions anytime you like, as soon as something occurs to you, and we'll deal with them as soon as we've done the presentation. Welcome, Phil. First time we've had you on a ShareSoc webinar, although you have been an attendee at previous ShareSoc seminars when we could all get together in the same room, and so it's nice to have you back.
Yeah, thank you. It's nice to be back as well, Mike. So, Hardide PLC, we can just move on slide, please. And, so obviously we've got the normal disclaimer that this presentation is just for information purposes. So move on to the first slide. So what is Hardide? Well, Hardide is a very special patented tungsten carbide nanostructured coating that's produced by a process called chemical vapor deposition, or CVD. But the original concept of Hardide is very interesting. It came out of the Soviet Union in the 1980s and 90s, where it was a fundamental research project at the laboratory at Moscow University. And following the sort of collapse of communism, a number of these technologies were touted around the West to see if they were interested. And an angel investor from Oxford saw this technology at a presentation in 1999, liked it, and brought one of the researchers, Dr. Yuri Zhuk, brought him and his family over to Oxford from Moscow in 1999, and the business started on a science park in Oxford and developed from there. So Hardide is a unique patented coating that has a very unique combination of properties that gives it significant advantages in the engineering industry. It's produced by chemical vapor deposition, which means that a mixture of gases inside the reactors, you can see two on the top photo there, the gases combine on the surface of the component, and the coating grows literally atom by atom on the surface, and therefore it can do things that other coatings cannot, like coating very complex shapes, insides of components, insides of cylinders, and very complicated holes, and non-line of sight areas, the parts that you cannot see. We provide a business-to-business coating service. Customers send their components to us, we coat them, and they get returned. We've got our main head office and production site in Bicester, just northeast of Oxford. And in 2016, we opened a facility in Martinsville, Virginia, in the States, to cater for the North American market, which was growing very strongly and still is. So our customers range from all the major oil service companies, and also people like GE, Airbus, BAE Systems, Leonardo Helicopters, EDF Energy, and many alternative energy companies as well. And unfortunately, because of the nature of the business, a lot of customers will not allow us to publicize their name. We're covered by a lot of non-disclosure agreements, both in terms of the customer and the actual components that we coat. So it does limit us somewhat in terms of promotion. And following a number of years of sort of private and PE equity ownership, the company was listed on the AIM market in April 2005. So we could move on, please. So a little bit more about the history. The actual company, Hardide Coatings Limited, was formed in 2000. After generating some industrial applications, moved away from the science park in Oxford to more industrial site premises in Bicester in 2003, and grew in those premises. As I say, it floated on AIM in April 2005. Developed the opportunities, particularly in the United States, which is a very strong market for us. And in 2016, we opened our facility in Virginia, 25,000 square foot facility, which we'll come on to a little bit later. Throughout this time, since 2008, we've been working particularly with Airbus to get approval of the coating for a replacement for hard chrome plating. And that final approval came through for the coating in 2017. And in 2020, we had outgrown our existing facility in Bicester and found new premises which were twice the floor area to give us room for expansion. Moved over there, and we completed that total move late last year. So we're now in a much larger site with, say, new equipment and a lot of room for expansion. But we are a leading global innovator of this advanced tungsten carbide metal coatings, and this is all protected by a very strong IP portfolio. We now have 6 patents registered since incorporation of the business. In 2019, we actually had a new patent granted for a variation of the coating, particularly for use on turbine blades for gas steam turbines and also for aircraft compressor turbines. So if we move on again to where we are around the world, so just a little map here, obviously main head office and our 22,000 square foot new facility in Bicester. As you can see there, we've got the 25,000 square foot facility in Martinsville, which we opened in 2016, which has plenty of room for expansion. We're not using anything like the floor area that we have there, so plenty of opportunity there to put more equipment in. And still have a relationship with Moscow. We have a research lab at Moscow University where some of the original scientists that were involved in the sort of 80s, 90s are still there. And we've also got new scientists involved in it, and they're continually working on new formulations, new variants of the coating with enhanced properties that potentially these could lead to further patents in the future. So just moving on to the technology itself. It is a true nanostructured technology. It's a tungsten carbide metal matrix coating, and the main effect of it significantly improves the working life of components. So the process is such that the components are placed in the chamber, heated up to around about 500 centigrade. A mixture of 4 gases is introduced into the chamber, and these gases react together on the surface of the component. And as I said previously, the coating is actually crystallized atom by atom over the whole surface of the component that we want to coat. We can, of course, mask certain areas of the component where the coating is not needed or not wanted. But this coating grows atom by atom. The layer builds up to a thickness of around 50 microns, which is around 2/1000ths of an inch, or roughly the thickness of a human hair. So that's the thickness of the working coating. As I mentioned previously, it does things that other coatings can't, particularly uniformly coating very complex shapes and inside and outside of surfaces. You can see there in the middle on the right there's a disc with hundreds of holes in. It's a plastic extrusion die where plastic is extruded through those holes and cut off into small pellets. We coat inside the holes in that component, which is something other coatings couldn't do. Next to that, there are ball valves, spherical ball valves. Below that, some pump components, and on the bottom right there are steam turbine blades. So it has a very high wear resistance, something like 250 times greater than uncoated steel. Because of the way the coating grows atom by atom, they all link together. There are no voids or porosity in the coating, so nothing can get through the coating to the substrate. So it's a very good barrier for corrosion and acids. And in the oil industry, which is significant to us, particularly there's H2S, hydrogen sulfide in the oil, which is a very aggressive media. And typically, the reports we've had from the markets are parts last 3 to 5 times longer than normal, and we have had reports of lasting up to 100 times than normal. And the zero porosity or zero permeability feature of the coating also opens up more recently for the hydrogen market, where we're looking at applications in hydrogen where the coating is a good barrier to stop hydrogen permeating through into the metal of whatever components being used. So all in all, we providing a solution to problems that engineers have within industry, and it's an enabling technology, enabling them to make more globally competitive components that they can then differentiate in terms of quality, performance, and life cycle cost. So if we just move on again to the technical advantages, because this is why the coating is used. It's the technical features of the coating that are very important. I keep saying that it coats uniformly complex shapes and internal surfaces, and this is probably one of the main features of the coating that why people are keen to use it. It's not possible with other similar coating technologies, including the more popular ones like HVOF, which is a high velocity oxy-fuel tungsten carbide coating, which is applied by effectively a flame spray gun, so it can only coat the parts you can actually see. And PVD, which is physical vapor deposition, as opposed to our chemical vapor deposition. And physical vapor deposition is again where you can transfer a coating from a source to the target component, but again, only by line of sight, by the actual areas that are visible. The features of the coating are that it has exceptional toughness, flexibility, and impact resistance. It can stand many deformations without cracking, which is very unusual for a hard coating. Most hard coatings are brittle, and if the component flexes or it bends, the coating cracks. With Hardide, that is not the case. The coating adheres very strongly to whatever component it's on, and does not crack, does not flake off. Very unusual property of a hard coating. The hardness of the coating can be varied, and we can produce anything from pure tungsten, which has a hardness of around 300 Vickers. Vickers is the method used for measuring hardness of these type of coatings, up to 3,200, which is effectively pure tungsten carbide. So anything in between, we've found by practical experience over the years that somewhere in the middle of that, between 1,100 and 1,600 Vickers hardness, is the best optimum place to be for wear resistance and erosion resistance. And that was developed particularly for the oil and gas industry, used on downhole tooling, which is very aggressive chemicals and also very high wear rates with particles of sand and rock impacting the component. And that's our most common coating. It's probably 90% of what we do is in that range. More recently, we've developed the aerospace variant, which is slightly softer, which is about 800 to 1,100 Vickers in terms of its hardness for various reasons. As I say, the thickness is typically 50 to 100. 50 is around 2/1000 of an inch thickness of a human hair. As compared to other coatings, it's in the middle. There are very thin coatings like DLC, which is a diamond-like carbon coating, or again PVD. These are typically 5 microns thick. HVOF, D-gun, other types of tungsten carbide coatings tend to be very thick in the millimeter range. So we're in that middle range where really nobody else has a coating that will fit that gap. Chemically very resistant because there's no porosity in the coating, so parts can't get through. On valves particularly, if it prevents leakage because the coating stays intact. The hardness of the coating, 1,100 to 1,600, was chosen because it's harder than quartz sand. So sand is ubiquitous pollutant or something that's found in many areas, and the sand will not scratch the coating. If sand does scratch a coating, then it forms a very small channel, and the high pressure fluid forces through that channel and acts like a jet, and effectively opens up greater and greater apertures in the valve, and therefore the valve leaks. So with Hardide, that doesn't happen. Another big advantage is that it's very smooth as applied because of the way it grows. It follows the profile of the substrate material very, very accurately. So just a very light polish with silicon carbide prep or something like that is sufficient to give a very good surface finish. Again, compared to other coatings, they require generally grinding or machining to bring them back to a good surface finish because they're quite rough as they're applied. And with Hardide, you don't get that. You get a very smooth, conformal coating. So moving on to the accreditations we have. It's fully accredited to many international standards. More recently, over the past few years, we've gained the Aerospace Quality System approval, which is AS9100 Revision D, the latest revision. And we're also approved to NADCAP, which is the global aerospace standard for manufacturing processes. It's run by all the major primes within the aerospace industry. Obviously to quality management system ISO 9001, and we're also approved to the environmental standard ISO 14001. So how have we performed financially? Well, over the past, since 2016, really over the past 5 years, we've shown very considerable half-on-half growth, and these graphs here are showing the half years, our financial half years. So you can see pre-COVID, we're on a very steep upward trajectory, peaking at in the first half of 2020, just sort of around 3 million revenue mark in the half year, so annualized at 6 million. And on that basis, we were just EBITDA positive at that point. And obviously, gross profit and gross margin have effectively followed the same trend. That COVID has hit our markets quite badly over the past 18 months. And we've had really three half years of fairly static revenue growth and similarly static gross profit. We believe that flat trend is now coming to an end. We're starting to get extremely busy. As you may have seen from our results that came out last week, we see the next financial year is particularly strong. We've got a very high order intake in the last few months of the 21 financial year. And the first quarter of this year is extremely strong. Orders are strong, sales are strong, and looking forward to a very positive 2022. One thing just to mention on the top there is our variable margins are well in excess of 70%. Even during the last 18 months, we're still maintaining 72-73% variable margin over that period. So in terms of market size, what's available to us, this is fairly old data, but it's all we have in terms of market data at the moment. That the industry is a huge industry. This is just UK data that the engineered coatings, and obviously there's a whole myriad of coatings ranging, from paints right through to what we do. So this is engineered coatings that perform a functional service within engineering. This is to say 2010 data, but £11 billion at that point. And within that, there is a range of alternatives that we can compete with in various areas, obviously not in every single area. So you can see there the average sort of 2010 annual market values and growth rates within the industry. It's a huge market that we've got to go for many applications. That's just UK. So our key markets are really split into. Can you move on, please? Thank you. Our key markets are really split into 4 main areas. We've got energy, flow control, power generation, and precision engineering and aerospace. So in energy, it's conventional oil and gas components. Say we supply all the major oil field service companies and a lot of subsea operations around the world. We're coating a number of components that see very aggressive conditions. On the left at the top there, you see a valving system that we coat the internals. In the middle, there's some drilling equipment. Flow control is pumps and valves. Severe service valves, particularly, again, seeing aggressive abrasive conditions. We have a large US customer that does high volume positive displacement pumps. Power generation, plastics extrusion, as we saw before on the dies. X-ray machines for airport baggage is a development we've worked on for some years, and now we're supplying a major manufacturer of very high speed X-ray baggage machines that go into airports. And on aerospace, BAE Systems, Airbus, Lockheed Martin, Leonardo helicopters, these are all current customers of ours on various platforms. The one thing I should mention, sorry, going back to the energy side, is alternative energy. We're obviously very aware of the move over the long term away from fossil fuels into other forms of energy. And we are currently working on a number of areas. We're producing or we're coating components that go into the production process that makes the raw materials to go into solar cells. That's a customer of ours that's expanding quite rapidly over the next couple of years. And more recently, we're in a development project with a large US company that's involved in electric vehicle batteries. So these are two new areas that we've recently looked at. So I'm just going to some of those in a little bit more detail. On aerospace, we're looking at fixed wing and helicopters. So on fixed wing, we're fully approved by Airbus. Both the coatings approved and the plant and equipment we have here is approved. This is being used as a direct replacement for hard chrome plating, which in its process uses very toxic, carcinogenic, hexavalent chromium salts, and that has been severely restricted under the REACH regulations. There was an extension till 2024, which is not too far away now, and most people have well through their process of converting away from hard chrome to other coatings, and Hardide has found a place within that, a very strong place, particularly with Airbus on that. And we're approved for parts for the single aisle, the A320 series, the A350, the A330, and also the A400M, the military version as well, with Airbus. So there's parts on all those platforms that we're approved for. BAE Systems, it was was the first aerospace business we got into. Back in 2005, I believe, we first started coating components for the canopy locking mechanism on the Eurofighter, and that's been ongoing business ever since. And more recently, this last year, it's been a very, very strong business. I think this has been the busiest year we've ever seen for these components since we started working with them. And we're also approved by Lockheed Martin on the F-35 Joint Strike Fighter for various components on that aircraft, on the A version, the F-35A version of that. So on the helicopter side, Leonardo helicopters is the main thrust of our development, both on rotor head components and also on the gearbox transmission system, where we've just been through a very extended test program where Leonardo are modifying a transmission system on one of the existing gearboxes to retrofit. They've been testing a number of components, of which Hardide is one of them, and that test has now recently been completed and has been very successful for Hardide and other components. So that is now going into the modification of the drawing system, and will be coming out for parts ordering very soon in 2022. So there's other helicopter manufacturers as well in the United States that we're talking to about other components, and also discussion with Airbus helicopters as well. So The next market we're looking at is power generation, which is a huge market size for us. Started working with EDF on this some years ago for the coating to protect steam turbine blades against a mechanism called water droplet erosion. This is where very fine water droplets impinge on these blades when they're going around at supersonic speed and really destroying the blade, causing severe damage on the blade. That work with EDF is still ongoing, but more recently we have been working with a European manufacturer of gas turbines, and we've just received in the last couple of months our first major order for that, for a rose on a new turbine that they're building, and that order is currently going through our facility, currently being coated as we speak, for delivery early January. And the reason our coating is being used on this is because it protects against erosion from water droplets, but also for corrosion. As a result of that, it obviously makes the blades last longer, but also improves the generating efficiency, which is very significant. And this particular coating variant was the one that was granted a patent for in 2019. And we're currently going through the process of having that patent registered in 10 major industrial companies around the world at the moment. But also in sort of power generation, I mentioned before, we're into solar cell market with the producer of raw materials that go into solar cells. Hydrogen, because of the low permeability or zero permeability of the coating itself, stopping hydrogen getting through onto the metal component. And also on wind turbine parts, we've identified various parts on wind turbines, particularly on the bearing system, that we believe Hardide can have a very beneficial effect. And we're currently working with a number of producers there to do initial testing to prove that case. So again, if we can move on, we're obviously, as a business, very conscious of the environment and our responsibilities under ESG and other things. And because we moved factory last year, we're ignoring what happened before and using the new factory as the baseline year for calculating our CO2 and waste emissions. And in our annual report, which will come out in February, there'll be a full ESG report showing data on this. But both the UK and the US sites are accredited. We eliminated the use of natural gas at our UK site. It was used at the old site. It's not used at all in the new site. All the electricity we buy now comes from renewable sources, and our waste is minimal, really. Our waste that goes to landfill is absolutely minimal, but most of any waste we have is recycled. And because we moved to the new site, we built it and designed it to be very energy efficient and very environmentally efficient to start with. So it'll be interesting to see what developments we can make going forward to improve the situation from a very good starting point. So moving on to where we are as an investment proposition, which is obviously what you guys are interested in. It is a unique technology. It does fill this gap within the range of competitors' coatings. The features are that it coats uniformly where other coatings can't, especially on complex shapes and internal surfaces. We've got coating facilities in the UK and the US, and we're enabling major blue chip engineering organizations to really make competitive products that last and perform better. Our revenue growth over the past 4 years prior to pandemic was very strong, and we've been obviously hit in the past 18 months, but we believe now we'll be back on that upward trajectory with our strong performance at the back end of last year and into Q1 this year. Our high variable margins and high operational gearing means that we don't have to add significant additional costs to do a lot more business. It's got its downside in the sense that when revenue drops, you've got a fairly high fixed cost that you can't shed or don't want to shed. So your margins get hit on the downturn, but certainly on the upturn, the the gross profit should increase significantly as volumes increase. The market size, as we've seen, is large, it's addressable. We've got a very strong position in oil and gas. It's been our major market for many, many years. But we are entering these new, very exciting markets now with Airbus, Leonardo, Lockheed Martin, and other aerospace components. Power generation opportunities, we believe, are absolutely huge. There's a huge number of blades per turbine that would benefit from the coating with Hardide. There's a lot of turbines out there. There's a lot of manufacturers of turbines. And what we're seeing currently is some a lot of interest in Hardide for this application. Our first major order is currently going through the plant. And we're just in brand new premises. There's pictures on the website, there's a video on the website, and we'll fly through the premises if you wish to look at that as well. But it's a very, very modern, very prestigious site that oozes the quality that our components are. So thank you for that. That's really the end of the presentation.
Thanks very much, Phil. I've got loads of questions here coming in, so I shall take you through them one by one. The first one, actually, we had a pre-submitted question from a gentleman called Ian King. He says, some years ago, Phil Kirkham stated the then large reactors took a year to order, cost about $1 million, and could produce revenue of roughly the same amount. What are the rough comparative figures for the new large reactors, and will we be likely to order the new ones in the future?
Sure, thanks, Ian. Yes, the lead time for a new reactor is somewhere between 9 and 12 months, depending on the particular time when we order it. But yes, we bank on a year from order to actually installation, commissioning, getting the thing running. And the smaller reactors are in the region of £750,000. The large reactor is obviously more expensive. That is in the region of sort of £900,000, and similarly, a year on delivery. Are we likely to order more? Well, we've got 4 standard size reactors in the UK and 4 standard size reactors in the US. So with plenty of capacity to take us, down the road a long way. And yeah, we typically use this sort of ballpark figure of around about £1 million worth of revenue per reactor per year, and that's very much sort of an average figure, taking into account the development work we have to, or development time on reactors we have to do. So they're not totally used for production purposes, but round figures is about $1 million. So 8 reactors in the group, you can see 8-9 million turnover with the current capacity. We installed 1 large reactor when we moved to the new premises this year. So we only got that 1 large reactor in the UK. At the moment, it's extremely occupied with the turbine blades that are going through. These are too large to fit into, or a number of them, about half of them are too large to fit into the standard size reactors. And whilst we don't see any need for any more standard size reactors for the foreseeable future, you can see a scenario if this turbine blade business and some other business, particularly on the electric vehicle side, because those components as well were also too large for the standard reactors, that this 1 reactor may not be sufficient, but that would purely be driven by the actual demand we would have for those components. Right. We're not there yet, and I don't expect to be for some time, but that would be the next foreseeable capital spend.
Okay, thank you. Just a subsidiary to that, seeing as I spotted it in the list here, what is the maximum number of reactors you can house in each site as it's presently designed, if you like, and how many more could you include if you were to expand on the acreage you already own?
But we don't own it. We lease.
Oh, lease it. Yeah. Occupy.
Occupy. Yeah. We could probably get another 3 reactors in the UK. And in the US, we've got plenty of capacity. We could probably get another 4 in the US. So in terms of footprint, floor area footprint, we've plenty of space.
Okay, thank you, thank you. Your technology will inevitably leak through Moscow to China. How will that impact your pricing? Interesting one.
I don't really see that. I mean, the fundamental technology has been around since 1980s, 1990s. We've developed that technology to become productionized, and there are many facets to doing that, and there certainly is a lot of intrinsic skill, black art, call it what you want, that we've learned over the years that makes this process work. And it is a process with many variables. It's not a simple process to operate. We learned how to do it by trial and error, by making mistakes. We've got a stable process now. We have for many years. It would take somebody a long time to develop something similar. We're well patented around the world. We've not seen any effort to replicate what we do from China or elsewhere. So we don't see that as a particular threat, although you can never say never.
Okay, all right, thank you. One here from Jocelyn Harris. If it is technically such a strong product and the market is so big, why are your sales still so modest? And as a subsidiary to that, which probably might go some way to explaining that, who are your main competitors?
Okay, so main competitors are not particularly individual companies, more technologies.
Yeah.
So we replace, particularly with Airbus and other aerospace components, hard chrome plating, which is a very well-known, well-tried, decades, if not hundreds of year-old technology that's now been, effectively banned, significantly reduced because of the health and safety problems with that. So HVOF, which is a high-velocity oxyfuel I mentioned earlier, this is another tungsten carbide type coating. That is a technology that can be used in place of hardide on some components. It really depends on the components. I say we've got the advantage on complex shaped internal surfaces where that coating can't be used, physically can't be used. And also the fact that these other coatings tend to have a much higher degree of porosity. So chemicals can get through to the substrate and cause corrosion. And we've seen this in many areas where parts have been historically coated with HVOF, and now customers are coming on to us wanting to discuss putting hardide on because they've seen corrosion issues with HVOF over the years. So there isn't one customer or one main customer that is a technology competitor to us. You say it's more different technologies, and as ever, it's horses for courses. We're extremely good in some areas, and other coatings will be extremely good in other areas. So it's really the application we'll look at. In terms of why haven't we got more revenue over the years, and it is an excellent product, and we have been going for 20 years, and I'm often asked this question. We are a relatively new entrant, even after 20 years, into a very traditional market. Most coatings have been there for decades, and many of them have not gone through the testing regimes that we have. In fact, Airbus said they've never tested a coating as deeply as they've tested hardide. They've inherited most coatings they use have been inherited, and they've actually very little test data, if any, on the actual coating itself. We're a disruptive technology. We're replacing other coatings, so we've got to displace something that's already there. So there's got to be a problem for an engineer to come and look for another coating. If the coating works, it works. It's not going to change it. So there's got to be a problem there to solve. So it's awareness of our coating has always been an issue. We spend a lot on marketing. We've got a very good website, I believe, which is very technically very good. That a lot of people come to us and find us through the website. Yuri Zhuk, our technical director, one of the original guys from Moscow, He's extremely well thought of in the industry, does a lot of technical presentations and papers and conferences where the technology is explained or particular application of the technology is explained. And we find that many customers have come to us through that route. They've been to a seminar, they've read a paper he's done, they've heard him talk. It's come at a time when they've been looking for a solution to a particular problem they've got. And they've contacted us, and we've developed through our business development people that opportunity. Mm-hmm. There's very long lead times on adopting new technologies. I mean, we were with Airbus, started with Airbus in 2008, and eventually the coating, not the applications, but the coating got approved in 2017. You know, that's 9 years. And Airbus tell us that 14 years is typical to approve a new coating in the aerospace industry. So it's difficult to get in, but once you're in, you're in. So once you've been approved on parts, the customer doesn't want to replace that coating and generally finds new opportunities. I mean, we've been working with some of the major offshore or oil field service companies since sort of the mid 2000s, and the product we first went on with them in those days is a small proportion of the business that we're doing now, because it's worked very well in that application. More and more applications have been found within that customer for the coating. Mm-hmm. We've got a very critical, you've got to get a critical mass and a credibility in the marketplace, and I believe we're now there now with the blue chip customer base we have, with the applications we have. We have that genuine industry credibility, and we're finding more and more people are accepting of the coating now, and more people are coming to us rather than us trying to find them.
Okay, thank you for that, Phil. It's slightly related. Tim Simpkin here says the delays in the Airbus Tier 1 supply contract have been incredibly frustrating. And can you provide any update on timing and when the contract and revenues will commence prior to 31st of March 22? I guess some of the things you've just mentioned probably have something to do with the delays.
Yeah, Tim, hi. As I said in the RNS, the interim prelims RNS that went out last week, we're purely waiting for Airbus and the Tier 1 supplier to sort their own commercial arrangements out between them. That's the only thing that's holding it up. We can't influence that. We're as frustrated as anybody the time it's taking, and Airbus and the Tier 1 just working at a glacial pace. We actually had a call with them this afternoon and trying to push this thing along, and it's like pushing string uphill. It really is. There's really nothing we can do. We're as frustrated as anybody. The delays that this is happening.
Okay.
So I just can't give any definite timescale because I just don't know.
Okay, thank you. Christopher Carnagan asked, do any customers refer to their use of Hardide as part of their sales promotion, rather like an Intel Inside sort of pitch to their customers?
The answer is yes, but very few. As I say, most of the customers are quite secretive about what they use because they don't want to let a competitor know they've had a problem and how they've got a solution to it. So there are a number of case studies on our website that customers have allowed us to develop with their cooperation and publicise. So they are using that as a promotional activity for themselves, but it's relatively few in the scheme of things.
Okay, just one on the related price, perhaps similar to ones you've already answered. Given the long developmental sales cycle and the fact that Hardide has a relatively unique product with the IP protection, I would have expected to see gross margins higher than present levels. What is limiting Hardide's ability to increase prices?
Well, gross margins tend to be reflective of this operational gearing that we have. So because a large element of our our production costs are fixed. As I say, increasing revenue will not increase our production costs anywhere near their increase in revenue. So gross margins will naturally just increase significantly as the volume increases for the plant.
Right. I think you said true variable margin is around 70 or something.
No, the variable margin is above 70%. It's maintained above 70% even during the last 18 months during the COVID restrictions.
Okay. All right. Well, thank you for that. What value of sales in pounds or percent of annual sales were made to aerospace customers in the financial year September 2021? And I think I saw a question somewhere about what do you do a sectoral revenue breakdown?
We don't. It's something I think we probably should do. We have done it in the past. We haven't done it recently. But our aerospace sales over the past year, I mean, essentially, the largest part of it has been to the BAE systems, the Eurofighter Typhoon. I think it's somewhere around 4 or 5% over the past year, that sort of figure.
Right. And it would, I think, I get the impression that would be quite useful now that you're generating more revenue.
Yeah,
just to get.
Absolutely. Yeah, it was something we talked about last week, and next time I think we'll put a sectoral split in.
Okay, thank you. Please, can you tell us the likely short-term impact on the share price of sales by EIS investors in the 2018 fundraise? I assume they're now able to sell at this point in the cycle, are they, or will be shortly? Any views on that?
I can't comment on the future share price is going to be.
I hope you were going to give me a price.
I wish I knew. No, I honestly can't answer that question because I just don't know. I mean, most of our shareholders are institutions, and they've been with us for many years. We've got one large family fund, the Boyce family, and Andrew Boyce is a non-executive director of ours. They've got a chunk, and the other shareholders, the top few tend to be major investors, major institutional investors who hold. They don't tend to sell. So obviously it's the retail market that tends to fluctuate.
Yeah, so it's relatively stable, I guess, going through the cycle. I've got one here. Please, can you describe your pricing model, percent of EVA or cost base, and how do you differentially price according to the value to the customer? And related to this, do you ever turn down a contract because it has too low a contribution from the price you can achieve?
Just taking the second part first, we always go through a fairly lengthy exercise with the customer to understand what their expectations are on price, because there's no point in us going through a development process and spending time and effort to develop the application to find out the customer then says, that's 10 times what I want to pay. So we try and filter all those things out first and make sure that the customer understands what sort of price bracket it will be in for that particular application if the testing's successful. So we have we turned stuff down? Yes, we have turned stuff down where the margins just aren't there for us. But we would not after we've done the development work. We'll sort that out before we do any development work.
And are you value based pricing it for the client, or is it primarily are you up against an alternative and it's a cost it's a cost competition that's going on?
It's generally not a cost competition. Obviously, some occasions it is, particularly on sort of more commodity type products. But generally, we're used because we are the best solution for the engineer for a particular problem that it has. There are many instances where customers have told us that no other solution would have worked for them in their particular application, and we do try and assess the value or the benefit of the coating to the customer and price accordingly. So we're not just on a cost plus basis or anything like that. We don't just say, well, let's think the cost and we'll add margin to it. We do look at all the implications for the customer as far as we can assess. Obviously, loss of demand was very forthcoming about it, but we try wherever possible to get that extra margin where we think the customers get an extra benefit out of it.
Okay, thank you. Is the low temperature hardide coating generating commercial revenues at the moment, or is still in technical testing?
No, that is still really a development coating. We've not done enough work on that to actually understand all the properties and put it out to the market as a commercial product. So no.
Okay. Would you be an attractive target for a larger player in the industry like Bodycoat, given that you've kind of got this niche product that would fit into their portfolio?
You'd have to ask Bodycoat.
Is it? Do you expect at some point to be acquired by an industry player, a much larger industry player, as you get to a certain size?
As I said, we've got a coating and a coatings range that nobody else has, and fits a gap in the range of other coating companies. So you could logically deduct from that we may well be attractive to a larger player, but who knows? I don't know at what stage that would happen, if at all.
No, I guess not. But it's useful to know your thoughts on the matter. Is it, as it takes a long time to get approval for each component, does this test become public knowledge when you get a customer who requires a similar test, or do you have to start from scratch with the new customer?
Yeah, obviously, if it's the customer's test, it's their knowledge. We can't use that testing, so we have to start somewhere else. We'd have to start again with a new customer. We try wherever possible to get those test results for ourselves as part of the deal we do with the customer. If we're producing components for him to test, we want the test results, which enhances our knowledge. We can't use those test results as they are with another customer, but it might lead us to, it might help us to direct our efforts in a different direction when we're dealing with another customer. We also try wherever possible to do our own testing at various laboratories, so we own that test data. And we've currently got some tests going on the hydrogen permeability, because we believe that's a big opportunity for us in the hydrogen market. So we want that data to be able to share and to use it for marketing purposes with customers. So we're having that work done, so we own that test data that we can then use. Okay,
thank you. Right, we're going to have to get our skates on. 3 minutes to go, so if you could be reasonably brief. We've still got 6 or so questions here. They keep coming in, which is good news, I suppose. A lot of interest. When you say you have cash for the foreseeable future, can you be more precise? The post-tax 2021 loss of 2.8 million and a cash balance of 1.54 million would suggest the cash will last around a year, even allowing for some increase in sales.
As I say, we think for the foreseeable future, I'm going to reiterate really what we said in the RNS, we believe the cash position is okay. Our sales are increasing, that drops through pretty quickly to the bottom line. If you go back to the graphs we showed before, in the first half of 2020, our revenue in that half year was 3 million, and we're EBITDA and cash positive at that point. We're very confident about this next year.
Okay, there's a similar question here, really. I think just read it out. Will you need to do a fundraising if you get the growth in sales you are hoping for? I think maybe there's an important not. You will not get the growth.
As I said earlier, we only foresee the need for extra capital. It would be the need for a second larger reactor, based on the fact that we've got more business than we could cope with on the current one.
Right.
In terms of the standard reactors, we don't see any need for any further capital investment in those for the next few years.
So to some degree, it would depend on what type of business comes in. If you've got more of the larger turbine blades, yeah, okay.
Well, would be overloaded, yeah.
A question here: what is the size of your addressable market? And that's probably quite a difficult question to answer. But
I just can't answer that. It's huge.
yeah. I guess in terms of some of the markets, you could probably have a good feel. You have a good feel for it now. If it's some of the markets you've been operating in for some time, I guess some of the new ones.
Those, new applications come to us regularly that we've never envisaged. I mean, there's a number just happened recently that we're working on at the moment, and the potential revenue from them, from 2 or 3 applications is huge that we didn't know about 6 months ago. It's a very difficult question to answer. All I can say is it doesn't limit us. The market size doesn't limit us. Doesn't limit our aspirations.
Okay, no, thank you for that. Oh, there's one here about somebody saw you in 2014 talking about the aerospace industry and the replacement of chrome coating technology on a range of applications. 7 years on, how much revenue has been generated from these, and how penetrated is this focused market? I think you've partly answered the penetration question.
The Airbus thing, which hasn't started yet. We've got a first few small orders through from Airbus, but the volume we're expecting has not yet started until we get this supply agreement sorted.
Right, and you referred to the conservative nature of the industry and the long cycle times there. The customer benefit is in saving cost of replacing worn parts. Surely that is readily quantifiable? ? So again, I think this seems to be a frustration about not having any market sizing here from people I'm detecting. But I take your point. It's somewhat difficult sometimes. Yes. Do you look at it even just by single application? You've got an application for turbines of this design, and you know how many there are in the world or whatever.
Thousands.
You just don't. How do you do your business cases? It must be quite difficult when you're setting off on a new development activity if you can't put a market size to something.
Yeah, well, if you're talking with one particular customer, it's a lot easier because they know what their potential is.
So you're working by customer size generally.
Rather than looking at overall market. If we're dealing with customer A, which we're dealing with at the moment, we in discussions with them, we know that they've got X number of turbines. They're thinking about putting us in Y number of turbines, and that gives us a potential revenue.
A reasonable feel, yeah. So it's a contract by contract basis, really, for that particular opportunity. Okay, no, I understand that. Okay, thank you. We quite a quick whip through at the end, so thank you for that. We're a couple of minutes over, but thanks very much for spending today with us, Phil.
No problem.
Appreciate it.
Thank you.
Me too.
For listening.
Well, I hope we could get you back next year and find out how it's going in the aerospace sector in particular. There's plenty of interest, as you can see from the questions there. Anyway,
great. Thank you.
I wish you a happy festive season in the meantime, and a wealthy and healthy new year.
Okay, thank you, and to you and everybody else. Cheers. Bye.
Cheers, Phil.